Is that coming in or is not? Mm,
No.
right. We are live. Recording has been started. All systems go. Okay, well, I tried. Uh, hey, folks, we're starting a little bit early, but we'll add some commentary on that. The first thing is LoFi.so. We're still trying to see how people like it. So navigate to that and then check it out. We kind of redid the local first web.dev page to be a little bit more splashy. If people prefer like sort of simpler, kind of very low frills kind of design as well, please do give us that feedback. We're kind of figuring out what works for the community and whatnot. But it's definitely a big upgrade. From the comments in the announcement thread, it looks like folks are excited about it. Today we have, as usual, an awesome lineup with Justin Mason and Mateo. The first speaker is Justin. This is apparently his second startup since COVID. And I'm excited to hear his talk about Rana and also all the work he's doing. The private data is the only moat left really resonated with me, and that's kind of where my company Vela.ai is also positioned around. So I'm really pumped to hear your talk, and I'll hand it over to you.
Okay, great. Well, thank you, Jans. So just let me share my screen here. And yeah, so this talk is replacing Google in the age of AI. Um, so this has taken me years of research, and I'll give you some background as to who I am. I'm the CIO and founder of Rana.ai. We're building a decentralized, local first AI ecosystem. So basically, it's our mission to democratize AI supercomputing to the world and have it be able to run on pretty much any device that is web compatible. So yeah, this talk isn't specifically about Rana's technologies overall, but only one aspect of kind of what we've developed. And we got into this sort of thing, yeah, a little bit before it was cool. Started research about a year before ChatGPT launched, so we've kind of been asking some of the right questions for a while, and it was nice to see the world switch from being obsessed with crypto to AI. So that was quite the nice change to see. So my career has been in cybersecurity, cloud, web, and data technologies. I founded Vermont's first hackerspace, Laboratory B, in 2009. A former member of Pony Express. We made, penetration testing devices. You might have seen Mr. Robot when he hacks into the jail. Like he used our phone phone.
Mm,
So my friends and I built that, and then I've been a DEF CON goon since 2012. So definitely recommend if you haven't been, come out to DEF CON. It's a blast, and yeah, everyone's super nice, and you'll learn just the most amazing things there. I started to develop for data science in 2014, and I got to work with one of the original members of the Google Analytics team when it was Urchin.
mm,
So I have a extensive background in the evolution of analytics and kind of the surveillance industrial economy as it's developed, and how to bypass it. So, so some of that has gone into the architecture that we've built, and I'll be sharing some information about that as well. How to opt out of that stuff. 2021, I moved to Puerto Rico and founded a healthcare software company for processing COVID-19 tests, which is now closed. But yeah, we processed over 200 million tests, and it taught me a lot about scalability, um, and how to design systems that can scale to infinity all at once. So we never had any downtime, no matter how many simultaneous requests there were, and it taught us a lot about the current state of cloud architectures. So yeah, I started R&D on Rana at the end of 2021, incorporated in 2022, and just to cover everything, I'm not a lawyer, but I may make predictions about the future, and nothing I say is investment advice. So, what am I building? Yeah, Rana is a distributed ecosystem for building collaborative, local first AI supercomputing clusters. The largest that we've built here internally is about 30 nodes, mostly MacBooks and things with unified memory. So, web GPU tends to run, exceptionally well on that. And everything's built on open source technologies, open data formats, open protocols, and open standards. The only proprietary part of this is the interface, literally the UI that wraps it all together. And at the moment, the two main components are known as Rana Engine, which is a web app for running AI and machine learning tasks, connects browsers together for clustered compute, and then run a bridge, which is a local API bridge to run an engine so that you have a programmable endpoint that you can access as a developer, like in your IDE, or if you're delivering services, you can connect your compute cluster via, something equivalent to a normal just cloud endpoint, but it's actually being run by your local mesh. Um, and then there's a lot more in development that I like to announce. But yeah, it's not quite ready. Still cooking. So I'll be posting in local first as it arrives. So I just want to lay the foundation for kind of where the industry is now. At the moment, we're leaving the information age, and I'm going to declare that the web is the new operating system. Hopefully, most locals first folks agree with me there. It can pretty much do anything that we want it to. And what's interesting is that everything old is new again. The original plan for the iPhone was to develop basically local first apps that were supposed to be web apps. And the advantage is that there's no middleman, there's no app store fees, no barrier to entry for developers. You can easily inspect these apps and debug them. It's more secure than native apps because of browser sandboxing. Like the browser is literally the most secure environment that we've ever created for computation. Well, technically WebAssembly is, but that's bootstrapped on top of it. So let's go with that. And then and all connections must use HTTPS at the moment. I've done a couple of demos in the past about security, like events at things like maker fairs and things like that. One of my friends used to work for Mozilla, and she organized some of these like privacy workshops. What we found was that at the time, this must have been about 2015 or so, um, the majority of native apps installed on both Android and iOS devices were actually not even communicating entirely in HTTPS. They were using HTTP, especially for analytics tracking. So there's just clear text like flying everywhere. Plus, if you don't use secure DNS, it's all just wide open. All this stuff can be, compromised, sniffed, cataloged for tracking, all that sort of thing. So, and yeah, there's really no disadvantage to using web apps these days. You have access to almost every chip in a device. So, web GPU, web VR, web USB, web Bluetooth. Yeah, I've flashed routers through the browser before now. I mean, it's pretty wild what you can do. So we live in a divided world as well. This is the consequence of the attention economy, and people suffer from information overload. Search is getting worse across all channels, particularly just to drive ads. Like this was a very intentional choice to increase quarterly earnings at the expense of long-term user satisfaction. There's decision fatigue. Users are asked to make too many choices, and we don't have enough confidence in those choices. This is the grocery store problem. We would rather have fewer choices and be able to trust those choices. And so the balance of what's on offer in the market isn't, kind of in the interest of the end users at the moment. Everything that optimizes for engagement mostly optimizes for enragement. So yeah, mental health continues to suffer based on the things that go viral, and all amplified by algorithms. The internet never forgets unless it's been intentionally censored. And then we live, yeah, in a surveillance industrial complex. You are your data, you don't own your data, and you are the product. And I have seen behind the curtain at Google, Adobe, Facebook, and hundreds of other advertising providers about how deep this goes. So, what can we do about it? We're going to move beyond this attention economy, and it's going to combine AI and human intelligence. So, we're able to use AI to help fight the problems of the past, but we have to be intentional about how we approach that. So AI is going to be the final everything blocker, not just ad blocker, but tracking blocker, anything you don't like. If you don't like spiders, you don't have to see them anymore. If you don't like the tone of a statement, you can ask the AI to pre-filter it for you. There's all kinds of things it can do. It's also a useful thought partner and tutor. Never runs out of patience. You can continue to explore any subject until you master it. But it's only AI is only as smart as the data it's been trained on and what it can reference, with limited capability to reason. This has been something that people have really struggled with recently. So we need to improve this, and humans will need to guide machines in the same way that we guide other humans, and supervise them in both public and private spheres. And machines have no lived experience, no feelings, and cannot empathize, and so may lack common sense because of this. How do we leverage AI? So we need shared understanding. Data is the new oil. It starts as crude, needs to be refined, becomes information. Uh, After it's been analyzed, then it becomes knowledge, and then the universal aspects of knowledge can be considered wisdom. So 80% of this is the data engineering, and 20% provides human value and meaning. It's same Pareto principle difficulty as everything else, but it's we have to slog through the first 80% before we get to the good stuff. And AIs need reliable knowledge and wisdom in order to establish context and human aligned intelligence. We can't expect them to discover it on their own, especially when learning from a place like the internet. So our problem is signal to noise ratio. This is the challenge as we enter the intelligence age. So the philosophical definition of knowledge is true, justified beliefs, and information is not equal to intelligence. So there's misinformation, which is just simple mistakes, people that get things wrong and tell each other honestly, but just were mistaken in some manner. Disinformation, uh, misleading claims, things that are intended to derail you or not leave you in a place to reason properly. And then the worst part of this is disinformation is usually partially true, but then they mix lies in or other things to kind of steer people wrong at the last second. And then malinformation, which is basically just inconvenient truth. that doesn't support agendas, narratives, or shared beliefs. So, without knowledge, we cannot properly teach or guide AIs to produce helpful results at all. So, public data is the foundation of abundance for the future we're trying to build. Right now, it's available abundantly on the internet. It's required for maintaining the accuracy and relevance of current large AI models. Model training will always be playing catch up by some degree because of data lag, and most data is time sensitive, and so it loses value over time since it's less correlated with the new configuration of reality. So the economics of public data at the moment, the social contract is of the internet is information wants to be free and sharing is caring. This is the world I grew up in. This is the world I would like to continue to, be able to support. And I have some solutions for how we can keep this. The use value of information does not diminish with the number of users. That's the thing that makes this magical. And unlike actual physical things in the physical world, no one is truly stolen from when information is copied. And the current anti-fair use arguments are probably moot, since these data gains value when it's liberated from restrictions. But some geological areas or political areas will have enormous advantages over others if they simply continue to use this data. So private data in the cloud is never private, really, unless it's end-to-end encrypted. That's a fallacy most people, are under. So you can't really trust the cloud. It's necessarily scarce and limited, but the nice thing is it is available to everyone in some amount. It is the last moat left because AI will drive the cost of software creation to near zero in the long run. So your private data, your personal data, that's the last thing you got to hold on to. And let's use encryption to make sure that happens. You can approximate the private data with synthetic data, but at necessarily lower accuracy due to chaos theory. Don't have time to get into why that is, but you can look that up and confirm. Um, Quantitative private data is only really valuable at scale, so that's what big tech's going after. Qualitative private data, however, is valuable even in small amounts. So that's things like the way you organize, label, and categorize things. And that's what the rest of this talk is going to be about. Local first software can help protect both kinds of private data because you run it locally. And encryption is the only guarantee that we have that our data will stay private. So encryption plus local first equals a future that we can all benefit from. Truth creates prosperity. So if you haven't watched, this is from They Live, very great movie. Strongly recommend it. So both knowledge and wisdom depend on truth and lay a foundation for justice and laws. Rules that make for healthy communities are often the opposite of those that make for healthy societies. This is so hard to communicate to AI. So for communities, we have norms, standards, and traditions, shared cultural preferences. For societies, we have rights, responsibilities, and freedoms that lead to shared civilizational values. And this is why we need this available to teach AIs properly. The truth can be profitable and can help fund journalism as competition increases. So Polymarket has already demonstrated that accurate predictions can be turned into profits. And chaos theory ensures that no model may ever perfectly predict the future. So there'll always be odds to bet against. Hindenburg research is another approach to this that can benefit journalism. But basically, if you tell the truth, you can make money. Although it's not legal to use Polymarket in all parts of the world. So yeah, it may depend on where you live. But it will fund journalism even if you can't control distribution. So how do we fit in here? Um, like machines need, since they have no lived experiences, preferences, or feelings, we need to sort of load information artificially that they can use instead, and that's going to come in the form of these knowledge graphs. So I'm going to skip ahead a little bit here. But how do we teach machines? We teach them rather than through brute force, like model training, we should offer them references in the form of knowledge graphs that they can refer to in the as a part of their context in different scenarios, so that they can establish those contexts consistently and have fresh data that is that had no need of repeating that like they can reference as a fact and hold that truth, as something immutable. And so, knowledge graphs provide that foundation, and then wisdom can be encoded in the form of constitutions or codes of ethics. And these will, sort of give that reasoning capability even to the most dangerous machines in order to not cause harm to humans or other creatures, that sort of thing. So this has always been the foundation of Google, is the um, Googlebot and their PageRank algorithm. So PageRank doesn't do anything without Googlebot. Googlebot fetches all the information. So yeah, all of this is going to be necessary to, we're going to need an equivalent of this if we're going to replace Google. How do we do that? We leverage Google's work through all the work that they've done in semantic web, through schema.org and similar types of um, schema encoded and structured data types of systems. So running out of time here, but it also, this is what powers the Fediverse. So these same schemas and JSON LD formats are what's behind the Fediverse at the moment. So I'm here to introduce my vision for this in the hypergraph. This is what we're building. This is what we will share with the world, and this will be available to every other developer that connects to the Rana ecosystem. This is like open format, structured data type of system that will be accessible through the gun graph initially, and then through APIs after this. But it is a um, open standard way of encoding knowledge to use as these knowledge graphs to inform AIs for the future. So whatever you need can pretty much be represented in this format. I'll try to hurry up here, but yeah. So the local first recommendations for this, if you want to be compatible and be able to leverage this, is just make everything JSON. Don't use YAML. Don't use TOML. Doesn't matter. Don't worry about transport as long as it ends up in JSON on the other side. And if you want to directly connect to the data that we're building, you can do so through the gun graph. Otherwise, we'll add API endpoints. Here's a quick resource. If you want to take a screenshot of this, I recommend grabbing this. But check out these various formats here. This really covers a lot of ground, and this extension here from OpenLink will help you find structured data as you browse the web. And this is kind of its example format. And so yeah, this is our last moat, so let's preserve it. But if we help each other to build these knowledge graphs and have reliable facts, knowledge, and wisdom, then we can all inform our AIs on ways to help them harmonize with human well-being and reflect our communities and personal values, regardless of those differences. And then we can build a future together where um, not only do we preserve sharing, but we extend that, to non-human entities as well. All right. So thank you, and yeah, we'll save questions for the end.
Thanks for the talk. Um, if you could stop sharing, I can introduce
Yes.
Jason. Next up, we have Mason, who will be sharing with us about diplomatic, repeat talker. And today I'm excited to get more in the guts of the details around what he's building.
Yes,
All
thanks for
right.
letting me come back. This is a much more detailed talk than before.
Yeah.
So,
Uh, Please
shall I get
stop
going?
sharing once so I can't cancel
Oh
sharing.
yeah.
There we go. Now you're back up. Go for it.
Okay.
Justin, you're already getting love on the chat.
All right. So I'm here again to talk about Diplomatic, which has been my hobby passion project for about the past year. And I'm calling it a protocol for making tailless applications. So let me just briefly describe how the talk's going to go. It's going to be technical. Um, there aren't any pictures. There are a few diagrams. There's going to be a lot of stuff and a lot of slides. So I'm going to talk quickly, I'm not going to talk through everything on the slides, but they're already posted, and this is slightly updated from what Jan's posted. So I'll post the slides again if anyone's curious. Okay, so in local first, we've talked a lot about sync engines, about the user experience you can get from operating on local data. So, you get like instantaneous UI updates, the developer experience. But I want to talk about something slightly different, which is once you've gotten your application off the ground and people are using it, now you have the operator experience to take into account. And
No, no. No.
so I've gone through this long process of figuring out how can you do this. And that's what this talk's going to be about. And this is what I call tailless applications. So headless software is basically no front end. Tailless is no back end.
Mm,
Now, not exactly no back end, but it's no custom back end that you have to run. Why is that? Well, backends they're a much bigger burden than I think we often realize. If you have an application that's popular and people are using and depending on it, which I think is the goal of all of us who build software, we want to build something useful. Well, when people start using it and depending on it, if it goes down, they're angry at you, and rightfully so. So you launch something that's got a backend. Now you've got a responsibility to keep it up. And what if you have a day job and it goes down during work hours? You can't respond. So if you're running something that you want to be available, you can't have a day job. So you need to have your application needs to be a business that supports you full time, or you don't have to work for some other reason. But even if you don't have to work, you still have to sleep. Your application goes down when you're asleep. You need an on-call rotation. So now you're talking about having a team. Okay. I mean, if you have a team, now you've got to have a business that supports multiple people. You're not going to have this from the start unless you've got funding. So now you need to raise funding before you can even start your project. And this is a really high barrier to entry. And this is going to be a deterrent to people who just want to build something that they're interested in doing, like tinker around with. And I think that it is very healthy when you have a lot of people who tinker and they follow their passion. So the question for this system is, or the question for me is, how can we build a system that lets people tinker, not have to worry about raising funding and hiring a team just to build their passion project, but still give end users the benefit of having a highly available backend service behind the application that they depend on. And I mean, there's even more problems with running a backend. You've got scaling, it's popular. If you're going to have people trying to hack you constantly, you'll see server logs. Everyone's trying to log in through SSH. They'll check for PHP admin scripts on your server. It's just nonstop. You have to keep upgrading your operating system. So it's no fun. We want to avoid that. So how can you avoid having a backend, but still get the benefits of having a backend? And the answer is we need to commoditize the backend so that there is a backend, but you don't run it. Someone who's a professional can run it. And ideally, there's a whole market of actually competing professionals who will run this standard backend. Then users can switch between them. Market forces can cause the best ones to rise to the top. You can stop working on your project, and your user can continue using this backend because someone else runs it. Like you're out of the picture as far as backends are concerned. So that's the state we want to get to. Okay, so how do we do that? Well, we need a standard interface between the client and server, and really between all clients and servers in this ecosystem. So normal client-server applications, your client and your server speak their own language to each other, and it's unique per application. So what we want is a lingua franca for all clients and servers. And then you just build a client that speaks this language, and then this whole ecosystem of standard servers, they can talk to your client application for you. Now, it's more than just communication between client and server that needs to be solved, but we also need the servers to just not care about who who's running these user applications, what content they're storing. And the clients need to also not care about who the servers are. Like, ideally, you don't have to trust these servers. They're just these anonymous service providers. And then from the server's perspective, we want the clients to all be anonymous. They're really pseudonymous. All right. So what does that look like? Well, the standard interface is just that clients create changes to their application state. and they package these changes in a standard little parcel. Then they use servers to move these parcels around the internet, store them and retrieve them, and synchronize them between devices. And then all these clients apply these changes locally. So I call these changes ops, which is short for operation, which comes from the term operational transform. Now, for a client to not care about who the server is, we need to encrypt these ops, because otherwise you have to trust the server is someone who's like a decent enough operator to store your private data. And you don't want to have that cognitive overhead. And also, companies can start out not being evil like Google and then say, actually, we want to be evil now, so let's strike that from the mission statement. So if we just encrypt our op data, then we don't need to care about how trustworthy the server is, because even if they're not trustworthy, they can't see what you're storing there. So who cares? They're just like, these servers, they're basically like self-storage businesses. They're just giving you empty space to put your boxes in, except it's even better because you have these like bulletproof boxes they can't open. So you're storing your like unbreakable safes inside of these self-storage units. All right, so that solves for the server being able to see your data, but we actually also want the server to not even know who you are. And the way we solve that is that clients don't identify with personally identifying information to a server. They use an asymmetric cryptographic key pair. So they just say, hi, I'm public key. And the server says, okay, yeah, I can tell that that's you. I'll take your data that I can't see and I'll stick it in this, standardized box here in my data center and give it back to you when some other device you have authenticates to me with the same asymmetric key pair. So we've got clients who don't care who the servers are, servers who don't know who the clients are or what they're storing. And then we've now got this wonderful state where no one knows who anyone is, nor do they care. You're just giving your bits to some provider, and you probably pay them. Now, payment is a little bit tricky because normal way people pay for stuff these days is credit cards, and credit cards transmit a bunch of identity information. So probably we don't want to pay with credit cards. We want something that's an anonymous payment system, but thankfully there are cryptocurrencies now that this is basically what they do. Okay, let's keep going. All right, so I described it at a high level that a change or an op is a description of a change in application state. Okay, right. I'm going to talk about that later. Sorry. Okay, so then what properties we want this system to have that is transmitting these encrypted changes to application state all around. And the property we're looking for is eventual consistency, which means that if you are a user who's got multiple computing devices, like a cell phone and a computer, once both your cell phone and computer have fully synced with these servers that don't know anything about you and you don't know anything about them, once you're fully synced, then you're going to see the same state on both devices. If you don't see the same state, your users get really unhappy. They tell you that sync is broken and they complain to you constantly. So I've run a service that has these kind of properties for many years, and we've had sync problems and I've seen it. So we want eventual consistency. We don't want to have any sync bugs. So I'll talk through how we achieve that a little later on. But here's a high level overview. We're going to relay these op data packets around so that everyone's got the same ones on their system. Then we're going to have a mechanism to sort them consistently on all devices. And then we're going to apply these changes to application state following the same rules on all devices. So once we've done that, we've got the same changes in the same order and applied the same way, you will come to the same end state on all your devices. Okay, here is broadly what the system architecture looks like. Can you see my mouse if I'm pointing to stuff? Yeah, I think you can. Okay. So basically the bottom half of this graph is the client side of things. And then the top half over here, this is what the server side looks like. All right, so this DSL part, this is an acronym for the diplomatic sync layer. this is where the magic really happens. But basically the way an application runs, we've got this view here. This is the user interface. And a user does something in their user interface. They click a button, they like type a text message or something, they save something. And that produces a change in application state, which is represented by this little op here. That goes into the sync layer. So then two things happen here. One, the sync layer encrypts that op and then sends it off to a backend. That's this path here. Then in parallel, that op goes through another path, which is it goes through a change handler, which determines how to take that operation and update application state over here, represented by the little database icon. And then once we've made a change in application state, then we're going to call a hook thing. This is React terminology, but basically we're going to notify the application's user interface that something has changed. So it can then change the user interface, and then the user can click another button and the whole cycle repeats. All right, and now I'm going to go through each of these, a couple different legs of the system. But let's start with that, what I call the data layer, which is where you go from having an op that's gone through the change handler and its mutated application state. Okay, so what's an op? An op, like I said, represents an update to application state. Okay, the state of the application is, it's a set of what I call entities. And these are going to be specific to an application. So if your application is a journal, for instance, your entity is going to be a note in your journal. If your application is some sort of graphical program um, like a vector art program, you're going to have shapes. It's a to-do list, you're going to have tasks, etc. Okay, every entity has a unique identifier. We call the EID. One of the properties is not exactly unique to my system, but it's an important property, is every op is a complete overwrite of an entity. Okay, so these are not delta coded. They're not just saying like, previously the note had the contents hello world, and now I'm going to add a period on the end. If you added a period on the end, then your new op is actually going to be hello world period. Okay, so just remember that. The reason I chose to do this is it is extremely simple, which has been an overriding concern in designing this system. And you might say this is very wasteful. There's going to be a lot of redundancy if you're incrementally changing incrementally changing an entity. Yeah, that's sort of true. However, you can throw away obsolete ops. You don't need to keep everything unless you want full undo history. Okay, so how do you throw things away? Well, if you got two ops that they modify the same entity, and you know that one of them, E2, comes after, in terms of temporal terms, comes after E1, just throw away E1. You've got all the data you need in E2. Okay. Um, if you don't do this, if you try to do things with diffs stacked on top of each other, if you lose one diff in the middle somehow, then you can't get to the right end state. So that's one of the reasons for doing things this way. Okay, and then how do you sort the ops so you know what to prune? My choice is that we're going to use timestamps. We're actually going to trust wall clocks in this system. And there's a little more than that. So, well, let me talk first about why you trust wall clocks. You don't trust wall clocks. You need some sort of conflict resolution strategy. And when you have people making changes on disconnected devices to the same entity, you can get into a state where you've got conflicts. And I do not want to have manual conflict resolution because it's such a pain. So the simpler solution is just we trust the wall clocks. So if a change has happened, one change has happened later, one change has happened earlier, the later one wins. Now, this system is designed this is designed only for single user applications. If you have multiple people making changes in parallel, then last wins isn't as good of a resolution strategy. But if you know that just one person is using this system, in my view, it's perfectly safe to just trust the wall clocks. I'm going to address clock skew a little later. There's another problem to deal with first, though, which is temporal resolution. I probably need to speed up, speaking of time. Okay, if you're doing machine generated changes and you have multiple changes that happen at the same time, like the same millisecond, then how do you sort things? The solution is you add an additional counter on the end. So you've got time and then you've got counter, which increases with each change that you make. I'm just gonna skip even faster through this. Clock skew. Okay, clock skew is when the clock on one device is at the wrong time, basically. So something's like far in the future when it shouldn't be. That can cause overwrites that shouldn't happen. That would be bad. My solution is still trust the clocks, but just detect it. So when you sync data and you talk to a server, the server can tell you what time it thinks it is. And then you can detect, oh, I've got the wrong time. So we can tell the user, fix your clock. Why not CRDTs? Um, let me just skip this actually. Okay, I don't think I'm gonna have time to go through the byte level stuff, but basically you're gonna have a header on every change. It's gonna have an entity ID, clock counter. We're gonna have a cryptographic, or sorry, we're gonna have a hash of the data, and then the length of the data that's gonna be stored in the body of this operation. What's in the body doesn't really matter. Actually, how am I doing on time?
No stress.
So I can
Keep
figure out
going.
how much to skip.
Yeah.
Keep going. Okay. Application can do whatever it wants in response to ops, but uh, as I've been building this, I'm building an application in parallel with the protocol, and I've come up with something that's very convenient for building apps, which is I call it Entity DB. It's just an index database that maps between the entity ID and then the current version of the state of that entity, which is just whatever's the most recently seen operation that modified that entity. So that the change handler just looks and sees, okay, do I already know this? I receive a new entity, or I receive a new op. Okay, do I already know about this entity ID? If I don't, just stick it into the index database, map from its ID over to the body of that operation. If I have seen that entity ID before, but this one I'm looking at is newer by looking at that hybrid logical clock composed of the timestamp plus the counter, okay, overwrite in this entity DB using the new body that I've got, and then tell the application something's new. Okay, and then what's inside of the actual body of the operation itself? We're gonna have a type. So if you're doing a note-taking application, it's probably note. The application itself determines how to interpret the rest of the contents of this operation. So I use message pack encoding. It's not really too important. Basically, it's just like a binary encoding. It's like JSON. So you put whatever is useful for your application in there. Um, let's see, on that entity DB, I'll check the created at and updated at using the timestamps from the operation itself, because you always end up needing these two columns in every application. Very commonly in applications, we need some sort of hierarchy, like your notes go inside of folders. Okay, I model this by, we already had entity IDs, but you can also have a parent ID, which is just a pointer to whatever the container is. It's very simple. And then I index on that. So you can do efficient queries and look up all the things that belong to a parent. Okay, skip that. How do we sync now these operations between all the devices we've got? Okay, there are many ways you can do it, but let me talk about the server-based method that I've got. We're gonna have to talk about the encryption that secures these operation packets so we don't have to care who the host is. And before talking about any sort of security or encryption stuff, let's talk about the threat model, like who we trust and don't. I trust everything on the top. The device, the operating system, the browser, the cryptographic routines that we use come out of libsodium. This protocol itself, although if you see flaws in it, let me know, of course. And then the application you have to trust, because even if all the rest is good, but the application developer built a backdoor in, then you're hosed. Okay, but we're not going to trust the network. We're not going to trust the cloud host. Okay, there's a famous thing, cryptography turns all problems into key management problems. So how do we manage the keys? Okay, there's one cryptographic seed. Everything comes from that. You generate it in the browser because, again, we're trusting the browser. That's part of the security model. So user clicks a button and we generate 256 bits of cryptographically secure random data. Okay, you have to do this up front because before the user starts using the application, because everything they do in it generates a change which has to be encrypted. We could defer this and do it later, but then you have the potential that people do they generate a whole ton of ops. And then when they want to link up with a server, now you have to go encrypt thousands and thousands of things, and it might be a really slow, bad experience. So I've just chosen we generate the keys up front. That made for an awkward onboarding experience because the way I used to store the cryptographic keys was trying to trigger the browser's password storage, which it's a little flaky. So I've got something better now. Let's let me skip that. Okay, so how do we store the key? The web, I don't know how they want you to say this, web often, whatever, passkeys. Um, the passkey uh, standard, it now lets you store a little bundle of arbitrary data using this large blob extension. And this is supported by Apple and Chrome. So it's supported everywhere. You can use it on an iPhone today. And I've got a little demo application if anyone wants to try. So what we do is that we generate this random 256 bits of data, then trigger the passkey dance, and then we can stick that 256 bits of data in the large blob extension, and it's going to get synced by Apple or Google through their ecosystem securely. We trust that it's secure because remember, we trust the operating system and the browser already. So this is not like diluting the security properties at all. We already trust them. Okay, but what if they go out of business? Well, ideally, we've got some backup for your keys because you need them or you can't see any of your application data. Okay, well, all the cryptocurrencies have the same kind of problem, and they've come up with various solutions. So you can turn your 256 bits of random data into these 24 words from this weird list of words, and I've got a link in the slides. But if you just look up BIP39, you'll find this stuff. And there are all sorts of ways you can like pound it into a piece of metal or something. Okay, I'm going to skip through the details of the encryption. I don't think there's time. But basically, there's going to be in these operation packets that we transmit through these untrusted cloud hosts. We're going to have okay, actually, this part I shouldn't skip through. There's going to be a plain header, plain text that the host can read. And then we're going to have an encrypted header for the operation. And then we're going to have the ciphertext, the encrypted operation body. Okay, so let's see. First, there is an index, which is the derivation index for a host-specific key pair. Okay, so there's one cryptographic seed the user has to store, but we're not just going to encrypt everything with the same key everywhere. We're going to have different encryption keys, but they're going to be deterministically derived from this one secret that the user has to secure. Okay, so we're going to encrypt things specifically for each host. Let's see, this signature here is an ED25519 signature of the hash. And you know what? I don't think I actually have time to go through all this. Let me skip through here. I don't want to burn up too much time. Let's see. We're going to change the encryption keys for every single op by deterministically deriving a new key for each operation that we sync to the servers. The reason for this is that if someone breaks the encryption on a single op, they don't reveal all of the ops that you've already synced to that host. If your master key, that one secret that the user has to secure, is compromised, then you're just in trouble. There's not really a solution to this. You're going to have to change the key and just re-import your data and start over. And unfortunately, if someone's got your master key and your data, they can read it all. And I'm just not going to try to solve that problem because I don't think you can. So it's important to just protect that one key. Okay, I'm going to skip this one. This is just an idea to maybe let agents write data to a little corner of your application without access to everything. Okay. Let's see. I talked about this at a high level. We're going to authenticate with hosts using an asymmetric key pair. We're going to deterministically derive that from that one secret that the user has to store. And the way you do that is that the host has an ID, and then we've got a cryptographic function to deterministically derive a key from your secret plus some other input, which is going to be the host ID. To register with a host, you get their ID, you derive your key pair that you're going to use to talk to them, and then you're going to register against that host with an endpoint they expose to you. They might require you to pay them here. And then after we've registered with them, then we're going to, in all future requests to the host, present to them your public key that you've derived to talk with that host, and then also a signature of something about the request so that they can verify that it's you who is making the request. Let me skip over this. Okay. See, what does the client database look like? Yeah, let me brush through this stuff somewhat quickly.
If you can wrap in a minute, and then we can come back for your demo and Q&A.
Okay. Yeah. This is about the detailed process for doing the synchronization. I don't think there's really time to talk through it. But it's basically how you achieve eventual consistency, don't have any gaps in the data that you synced. We're going to sync upload and download work queues. So there's going to be an endpoint to talk to the host and find out like what operations does it know about, and then you can reconcile that with what you've got and figure out what needs to get uploaded and downloaded. How to go through the upload process by sending a batch of things at once. The server can tell you what it got okay versus not. You can retry. Downloads are very similar. Once you've done a sync, here's a mechanism by which you can check that the host has all the data that you think they've got. For a really detailed check, you can have them ask them to audit the bits they've got on disk by presenting them with just a random nonce, and then ask them to do a checksum that's salted with that nonce you send them, and then compare it against your own. So you can get a greater guarantee that they have your data than we currently have with any cloud host I know of. Yeah, how to rotate keys if you need to. Skip through that. What the API looks like. A host gets an update and it can broadcast via WebSockets. It got an update, so you get real-time updates. Okay. Yeah, ignorance is bliss. Let's leave it at that. What's the state of the system? I've been building and using it for months, but this is my design for the version 1 release candidate, based upon some of the issues I've run in with V0. Okay. If anyone saw any flaws, you can flip through the slides after if you're curious. If you find flaws there, let me know so I can fix it before I publish a V1 of it. All right. Thanks everyone for listening.
Thanks, Mengza. And the guts of trying to do OTs is never an easy problem. And what better way to kind of have a follow-on talk than somebody implementing a P2P markdown editor? Matteo, I'm really stoked that you added the changes you made for this demo specifically. So over to you.
Hi everyone. Well, first of all, thanks Jons for this space and let us showing our projects. Really interesting both talks. Congratulations, Mason and Justin. So, well, I'm here to present MD.UI. It's an experimental project I built a few weeks ago, and I'm still experimenting in. And it's basically a markdown editor that syncs peer-to-peer with peer-to-peer technologies. And as you can see, and Jones just said, I added this present functionality for this talk. So this is md.ui. First, about me, I'm Mateo. I'm from Montevideo, Uruguay, so probably far away from most of you. And I'm an industrial designer that made a pandemic pivot, and I currently work as a web developer and also as a designer, and I work as freelance. And my passion is building stuff in the web. I'm really passionate about web technologies. So I believe that one of the problems because all of us are here, is because software has become too server-centric, and this has some trade-offs. For example, internet connection nowadays is required to running most of our software, and we are highly dependent on third-party infrastructure. And I believe that the worst problem of this is that we are losing ownership of our data. So I'm going to tell my note-taking story. I used to use an application called Reflect Notes that is really, really good. Awesome UX, awesome UI, works perfect. But one day I just stopped paying because I wasn't using it much. And suddenly all my notes were view only. I don't know if someone of you ever had this problem, but it's quite terrible. And that took me to the question, oh, these were actually my notes, or they were Reflect notes, and if I pay, I can access them and I can edit them and I can use them. So this then took me to try Obsidian, but Obsidian, although it worked local first and I had all my files in my device, felt like sync was not in their core, and also it was a paid service, and that totally makes sense. I'm not saying that Obsidian is a bad company because they run their servers and sync runs through their servers, so it totally makes sense to them to charge for this service. But this took me to this question: can I build an application, a notes application that syncs without this central server, and I don't need to run all this complex infrastructure to collaborate with coworkers and share notes and all this kind of stuff? So, well, I was already studying stuff around the local first ecosystem, and I rapidly got into YJS. That it's, I believe that most of you might know it. It's a CRDT implemented in JavaScript. It's really optimized. It works very good on the web. And if you don't know it, it's kind of a Git for real-time collaboration. You have a document, and all people that are working together in this document can make changes, and this will sync automatically, and YJS will handle all these conflict resolutions automatically. So yeah, it's a very good option to create this collaborative web application. So here I show how basically you create a Y document that is where all these CRDT data structures will live, and we can share this YJS document with other peers, with another server, and we just can all edit and have a really good experience working together. And the good thing about CRDTs is that we don't necessarily need a central server to merge these conflicts. The data structure itself has all the data needed to automatically merge. So this enables peer-to-peer collaboration without needing a central server. So then I got to WebRTC, that is a peer-to-peer technology. It basically allows us to connect between devices. So my computer and my mobile phone and maybe a coworker's computer that we are working together in a document can communicate together and can share that data between them without needing this central server. So this was a perfect match for the idea I had, because yeah, I could basically share all this stuff without the need of running complex infrastructure. And also YJS has really easy way to integrate them, so it was quite straightforward building this connection. So what I build is this editor I'm sharing. It's called md.ui. It's a combination between Svelte, the front-end framework, Code Mirror, that's the code editor you see here, that also it's very straightforward to use and to combine with YJS, and WebRTC for the synchronization layer. So for the synchronization, I don't need a backend nor complex infrastructure. And as you see, you don't need a user account to run the application. It works okay offline, and you can edit your notes and all your documents offline. Also, it's installable through the progressive web application technology. I have it installed here on my device. You can install it in your mobile phone, and it just works. So the future of the project, I will continue exploring how far I can get without running complex infrastructure. Because of course this makes users dependent of the people that run this infrastructure. That is something I don't want, and I also don't want to run through expensive hosting and through setting up all this stuff. And next in my roadmap, I want to include encryptions to the documents. I also want to add backup strategies, so it's easy to back up all these nodes, maybe into our local file systems of our devices, into S3, Google Drive, durable objects. I just have to experiment with these options. And of course, exploring more sync options through WebSockets, for example, if there is not a peer available to share the state of the document. So thank you very much. And for this demo, I want to show some functionalities here. So this is my document. I just created all the presentation here through Markdown. I can preview my presentation in this mode, or click here to present as I showed before. And I will show how the share technology works. Basically, I added two ways of sharing documents: a live sync mechanism, that is the one that I talked about, that is done with WebRTC. So if I generate sorry, I was in the static share here in the live sync. If I start a sync session, everyone here can go into the document and start editing. So please don't change my presentation, but you can come in here and work. We can work together in a very easy way. And also I will turn it off. And also I will show it with this other node. I can share a static version of this node. For example, if I want just to get my node, but I don't want to collaborate, I don't want you to edit my node, I just want you to have your own copy of what I done in your md.ui instance. I can generate a static link here. So if someone wants to get all these links of the presentation, I created a Discord server for the application. You just scan here, or I will share this on the chat. Just a second. The chat is here. So here you can import the node, and you will get it inside your MD instance. So well, thank you very much. I invite you to test the application. It's super open to collaboration. I will be adding more experiments to the app. Please don't put super important stuff here because it's in an experimental state, the project. So please back up any important note you take here. So well, thank you very much, and thanks again, Jones, for the opportunity to show our work.
Mateo, that was like a wonderful presentation. And then the fact that you can
Thank you very
turn
much.
two dashes that gets you a slide, that's pretty cool. All right,
I
Rana.
sent the invitation to the Discord. I just created for the talk because the project is quite new. I didn't have a Discord server.
Yeah, hope that people check it out. Back to you, Justin, for a quick demo, and then folks on the call, drop your questions in the chat. Mateo, if you wanna, yeah, nice.
Okay, awesome. Just gonna share this. Is that coming through?
Yep.
Okay, cool. So here is an example knowledge base that I've created in Rana Engine. At the moment, out of the box, you can make new note cards or new wiki cards. So these have been made from wikis. These are some of the books and other things that I've sort of read, for inspiration in trying to build Rana. So we ran all of this information through some of our machine learning models when creating the um, text and content that we're going to populate this with. A lot of this has been sourced from Wikipedia, so you'll get some of the various, book covers and things, but it's, open data that's available. Then if you flip over any of these cards, then you'll notice that everything has been encoded in JSON, and that a lot of these key value pairs will correspond with some of the schemas that have been available. Now we've also chosen to encode the images in base64 directly into the card to make them self-contained. So there's more that we're doing to extend the compatibility with some of the different schemas in this, especially as we're starting to develop additional capabilities around the Fediverse and ActivityPub protocol and some of the other um, schemas that will be available. Like, for example, I don't have anything geo related at the moment. Eventually, we'll have geo cards, so we can, map places in like a open format that correspond to things on the map. But
Nice.
yeah, this has been a very fruitful approach to encoding information and passing it around, since like not only can everything remain self-contained, but you don't leak data. So if you're normally attempting to resolve images that might be loading as part of some of this information, that's effectively a tracking pixel. Like before cookies and everything, these little 1 by 1 pixel transparent GIF files were embedded, and those web bugs on the net, and it was to just generate a server request to some sort of third party domain, and then they would log things like your user agent, IP address, the ping and all that sort of thing that would provide for server-side analytics tracking, across the net. They still do that with emails as well. If you allow external images to render in email, then it will effectively leak your information. So that's the thing that we're trying to avoid, because I really want to live in a future where I can trust the tools that I have built and depend on, and not kind of be subject to the same level of tracking that's come before. Like I said, AI is going to be the universal everything blocker, and the advertisers don't realize this yet. They're it's like Icarus. They're gonna fly higher than ever. The returns will be higher than they've ever been, and then the whole system's gonna crash. So it's because yeah, you won't have to see anything you don't want.
Yeah.
For example, the like Meta Ray-Ban glasses, or the Google, what do they have now? The
XR.
yeah, the ones that they're working on anyway, the Warby Parker, those ones very soon will be able to overlay things in AR as you walk down the street. So you could literally see a poster for something, and then like you can just block it out. Like you don't have to actually see the ad at all, even though it's like printed in real life. So
Gotcha.
um,
Gotcha.
yeah.
Um,
Anyway, so yeah, let's build a future that's open, and that we can share, and that we can teach our values to the machines we depend on, and yeah, just have a great future.
yeah. I would love for you to share your slides too. Mason, did you still want to do a quick demo?
No, that's okay. I'll skip the demo. I mean, I have an application, but that's not really doesn't show anything specific about the protocol.
All right, gotcha.
It just uses it to sync, but any old application with a sync engine, it would look the same.
Thank you to the speakers. I'm going